Hey, hello everyone. Welcome to our channel Physics, where we actually learn physics. So in this lecture, we are gonna start with this additional exercises from our 11th standard. Okay, 11th standard. This is chapter 2 actually. This is chapter 2, that is units and measurements. Okay, we are in the CBSE board. Okay, so let's talk about this. First of all, you can see this question is a man walking briskly in rain. Okay, a man walking briskly in rain with speed v must slant his umbrella forward, making an angle theta with the vertical. Okay, a man walking briskly in rain with speed v must slant his umbrella forward, making an angle theta with the vertical. A student derives the following relation between theta and v. He says it is tan theta is equal to v. This is what he says. Okay, so let's highlight this. Okay, this is what this student has derived. Okay, tan theta is equal to v, and checks that the relation has a correct limit. Okay, checks that relation has a correct limit. That means as v tends to 0, theta also tends to 0. Okay, as v tends to 0, theta also tends to 0, because this equation you can see as theta becomes 0, v also becomes 0. So this equation is correct from the limits point of view as expected. We are assuming there is no strong wind and the rain falls vertically. Okay, it's vertical rain for a stationary man. Do you think this relation can be correct? If not, guess the correct relation. Okay, see here, the relation is given like this: v is equal to tan theta, or tan theta is equal to v, whatever. Okay, now the question is whether this equation is correct or not. Okay, if we consider the limits that is given over here, you can see these limits. According to these limits, the equation is perfect. You can check here. If you put theta equal to 0, okay, if you put theta equal to 0 degree, then v is also going to be 0. Okay, v is also going to be 0. So that's no problem at all. Okay, there is no problem with this. Okay, so this equation is perfect. Okay, from the point of view of the limits that he has chosen, but we have to actually find out whether this is correct or not. Okay, and what is the method to find out whether any equation is correct or not? There is only one method, and that is the dimensional analysis. Okay, so we have to use dimensional analysis. Now, what does this dimensional analysis say? What is dimensional analysis? It's very simple, right? Each term in the equation like this, okay, the RHS and the LHS, both should have same dimensions. Okay, both should have same dimensions. Okay, like for example, when we say dimensions on LHS are m1, L1, t minus 2, then on the RHS also the dimensions must be same. Okay, even though the quantities may be different on LHS and RHS, but when we solve for the dimensions, we must get same dimensions on both sides. That is the most important condition over here. Okay, according to dimensional analysis. Okay, this is called as principle of homogeneity of dimensions in an equation. Okay, so that should happen. So let's check whether this equation has got same dimensions or not. Check it. there is no correctness in this equation. Actually, if you see, LHS is v, and here there is no term of velocity. Okay, there is no term of velocity on the RHS. There is tan theta, and tan theta or any other trigonometric function does not have any dimensions at all, isn't it? So that means the LHS has got dimensions L1 t minus 1, because it's velocity, length upon time, and this has got no dimensions. That means L0, t0, okay, whatever, or m0 also. Okay, so there is no dimension on RHS, and LHS has this dimension. Okay, so that means what? This equation is dimensionally wrong. It is not dimensionally correct, or this is not dimensionally consistent, or it is not dimensionally homogeneous. There are lots of words for this actually, lots of phrases actually. Okay, so in this way we can just directly rule out this equation that no, this cannot be correct equation. See, if you want this equation to be a correct equation, there should be some term related to velocity on the RHS also. See, this is our equation, v equal to tan theta. So here there should have been some velocity actually. Okay, there should have been some velocity, let's say v naught, u naught, whatever, that we have to find out actually what, but there should be some kind of a velocity of the rain or velocity of the wind, whatever, okay, whatever you think, but there should be some kind of a velocity on this RHS, okay, or any other term which would give us a dimensions L1 t minus 1, okay, on the RHS, but this is not there, okay, but this should be the actual form actually, okay, something like this, okay, either you can write it like this, v equal to u tan theta, whatever, or you may be having v equal to v naught plus u, something like this, okay, tan, whatever, because this term also has the same dimensions, this is velocity only, okay. So somehow we must have velocity term on the RHS, then only this equation can be dimensionally correct, otherwise no, this cannot be, okay. So this is a wrong equation and this should have been in this form that I have given over here, okay. Exact equation we cannot derive right now because we don't know the exact conditions, okay, some only few conditions are given, so from those conditions we cannot derive the right equation, but we can estimate a right equation or at least the right form of a equation. That is what we have done over here, okay. So anyways, we will stop over here. I feel this is it right now, okay. I mean, this is the answer for us for this question, okay. So I hope this is clear why it is not correct and what can be the right answer to this, okay. If not, you can ask me in the comment section if you want. If you have any questions, you can ask me, okay. So again, thank you so much, okay. Now I will leave from here. Thank you so much. Bye bye. See you. Have a nice day.